In Japan, heat stroke due to high temperatures in summer is a major health issue that is often reported in the media. The number of deaths due to heat stroke is higher than those due to other natural disasters, such as typhoons, tornadoes and floods, with several hundred deaths per year. In recent years, the incidence of heat stroke in Japan has increased owing to the urban heat island effect and climate change. If the trend continues, the number of heat stroke patients is expected to increase further in the future. Therefore, it is advisable to develop adaptation measures for the worsening heat environment. Establish evaluation methods for various adaptation measures and better predict the urban heat environment. The Center for Computational Sciences at the University of Tsukuba is developing an urban climate simulation model called CityLES, which can predict urban climate and the risk of heat stroke. CityLES uses supercomputers to solve fluid dynamics equations and radiation equations to predict and reproduce the weather conditions inside and outside the urban districts with a spatial resolution of 1 meter to 10 meters in detail. It differs from standard numerical weather prediction models in that it considers buildings and street trees both inside and outside urban areas. It is also different from standard computational fluid dynamics (CFD) models, as it considers atmospheric stratification, atmospheric radiation, clouds and fog in the model. CityLES can also run on a graphics processing unit (GPU) cluster. Researchers of meteorology and high-performance computing systems associated with the Center for Computational Sciences (CCS) have teamed up to develop this model and perform the numerical simulations on the Cygnus supercomputer at CCS.
CityLES can predict and reproduce the thermal environment of urban districts in detail. In addition, it can evaluate the effect of mitigation strategies, such as green roofs, cool roofs, street trees, dry mist, and thermal barrier and pavements.
This figure shows the temperature distribution around Tokyo Station on a summer day, as predicted by the CityLES. Red indicates areas with relatively high temperatures, and green indicates areas with low temperatures. The Imperial Palace, which is covered with trees and grass, is predicted to be cooler overall. Even though on the same road, Hibiya-dori Avenue along the Imperial Palace moat is predicted to be hotter than Gyoko-dori Street, which is in the valley of the buildings. We conducted meteorological observations near the Tokyo Station to understand how accurate the CityLES predictions were, and our findings are presented in this figure. The circles indicate the observed temperatures. The predictions have slight errors at some of the locations, but the model overall predicts the observed temperatures very well. As shown in this figure, locations predicted to have high temperatures, such as Hibiya-dori Avenue, actually had high temperatures, while locations predicted to have low temperatures, such as Nakadori Street, actually had low temperatures. Predicting the wind is also important for predicting the heat experienced by people. When there is a breeze, we feel cooler, and when there is no breeze, we feel hotter. This figure shows the distribution of winds at the same time as predicted by the CityLES. Red indicates windy areas, and blue indicates calm areas. The arrows indicate the wind direction. It can be seen that CityLES can accurately calculate complex wind fields within a city centre. Let us look at it in detail. The red arrows indicate the observed wind direction. purple circles are calm points with wind speeds of 1 meter or less. The wind is predicted to blow from the front of the Kitte building to the front of the Shin Marunouchi building and down Gyoko-dori Street. Weak winds were also predicted to blow on Babasaki-dori Street in front of the Tokyo International Forum. Although it is generally difficult to predict the strength of the wind on the same street, CityLES was able to predict the strength of the wind along the Nakadori Street. As predicted, the wind is stronger on the south side and weaker on the north side. This is worthy of special mention. It turns out that CityLES can predict complex wind patterns in urban areas very well. The heat that people experience is determined not only by temperature and wind, but also by radiation. We feel hotter not only when we are exposed to sunlight, but also when we are exposed to infrared rays from hot roads. Therefore, we investigated the accuracy of predicting the road surface temperature distribution around Tokyo Station on a summer day. The figure on the right is the observation result from a helicopter, and the figure on the left is the prediction result. They are very similar to each other. At a glance, it is difficult to determine which is the prediction result and which is the observation result. We can say that the prediction of the road surface temperature with CityLES is highly accurate. Let us examine Yaisudori Avenue. The CityLES model accurately calculates the locations of sunshine and building shadows. The spatial resolution of CityLES is extremely high, and since it can directly calculate large eddies within the atmospheric boundary layer, it can explicitly calculate the thermal convection that occurs in urban areas. This is another difference between general weather models and CityLES. The strong thermal convection created by cities often generates clouds. CityLES can therefore also simulate small cumulus clouds that form above the atmospheric boundary layer in urban areas. This is another feature of CityLES that is not found in the CFD models.
So far, we have developed the CityLES. In the future, we plan to use this model to address open issues in urban meteorology and climatology, and use it even to propose better mitigation and adaptation strategies for uncomfortable urban summer environments.
In the future, we would like to make CityLES widely available to the public and hope that many researchers will make use of it. As more researchers use CityLES, urban meteorology and climatology will be further developed, and better future predictions of urban thermal environments will become possible. We would like to start a new project with you. We are waiting for you.